Hello everyone. Our today's topic for the A-level chemistry is carboxylic acid and their derivatives. Carboxylic acid and their derivatives. Now, the general formula for the carboxylic acid, as we have already learned in the previous classes, that is CnH2n plus 1 COOH. The value of N starts from 0, 1, 2, 3, 4. If we put the value of N0, then we get the first member of this homologous series as HCOOH, which is also called as methanoic acid because one carbon atom is here. If we put one value, N value 1, it will become CH3COOH, and then so on. As we continue adding N value, we will get the respective carboxylic acids. Now, this is methanoic acid, ethanoic acid, propanoic acid, butanoic, pentanoic, hexanoic. We can get a homologous series of the carboxylic acids. Now, we have to discuss the acidity of the carboxylic acid. The first member, methanoic acid, is the strongest acid in this homologous series. Why it is? Because the carboxylic acids are represented just like this. The first member is HC double bond O and H. Now, this bond between oxygen and hydrogen is polar. This is polar. Partial positive charge comes on hydrogen and partial negative charge comes on oxygen. Now, the carbon attached with hydrogen or the hydrogen which is attached with carbon, that cannot be ionized, that cannot be polarized because the electronegativity difference between those two atoms is negligible. Now, remember, the electronegativity of carbon and oxygen is more, due to which this oxygen and hydrogen bond become apolar. Due to the electronegativity difference, oxygen gets partial negative charge and hydrogen gets partial positive charge. Now here, the positive charge also created on this carbon atom. Now as we know that on the left hand side only one hydrogen is present, which is indicating that it has only one electron which is already used up in the covalent bond formation with the carbon atom. So this positively charged carbon cannot gain more electron from anywhere from the left side. That's why it will definitely pull the electron of oxygen towards itself. Pull the electron towards itself. As a result, what will happen? The electron pair present between oxygen and hydrogen will be tilted and it will become much closer to oxygen atom. So the breaking of this uneven oxygen-hydrogen bond become quite easy. That's why this will liberate H positive ion and become ionized as compared to the other. Next, if we replace this H by a CH3, now what will happen? As we know that the alkyl group are electron donating group. They have nature. Why? Because in this case, when the carbon will form bonding with this carbon having hydrogen, it means that now there are total 10 electrons present with this carbon atom, and that can be shifted towards this carbon atom due to the positive charge of carbonyl carbon. So the positive charge of carbon will become a little bit less. So now the pulling of electrons from oxygen will become less, and the pair of electrons present between oxygen and hydrogen will remain approximate between the two atoms. That's why due to the presence of electron pair between the two atoms exactly at an equal distance make the bond more stronger. The ionization of the acid, in this case removing H positive ion will become little bit difficult. So the strength of ethanoic acid will become lesser than methanoic acid. Again, similarly, if we increase the chain length more, then more electrons can be shifted towards this. And further, if we change the hydrogen of this adjacent carbon with another alkyl group, then it will increase the stability and will further decrease the ionization of the acid, and acidic strength of this 2-methyl propanoic acid will be lesser than the just only propanoic acid, and even that will have lesser than the ethanoic acid, and ethanoic acid will have lesser acidic strength than the methanoic acid. Now, here in this case, on the left side, as we have discussed the electron donating character of the alkyl group, if we replace these groups, by electron withdrawn groups, for example, if we replace one hydrogen with chlorine atom, it means that the electronegativity of chlorine is more, so electron will be attracted more strongly by the chlorine. So this carbon cannot provide electron to this carbon atom, so the pulling of electron by this positively charged carbonyl carbon on the oxygen will become much more, due to which this pair of electrons will stick with oxygen, and the ionization of this acid, chloroethanoic acid, will be increased considerably. Now, if we replace all these hydrogen atoms, this hydrogen with also chlorine, again strength will be increased if we replace this chlorine. Further, it means that now the pulling of electron by this carbon atom due to the presence of all these three chlorine atoms will become much more, and the acidic strength of the trichloroethanoic acid will be increased too much. In this manner, the acidity of the carboxylic acid can also be increased. Now, from this we can represent the acidic strength, as acidic strength will be represented just like this. Acidic strength will increase from top to bottom in a homologous series of the simple carboxylic acids. Next is the derivatives. What are the derivatives? These chloroethanoic acid, dichloroethanoic acid, trichloroethanoic acid, or the all other compounds which are prepared using carboxylic acid as a starting material, all those are called as derivatives of carboxylic acids. Now, next, there are two carboxylic acids which are little bit more stronger reducing agent than the normal carboxylic acid. For example, we know that in case of alcohol, OH, we have already learned that if we oxidize alcohol, then these will be transformed into the carboxylic acid, which on further oxidation will not respond, or the further oxidation of this carboxylic acid cannot be performed. But there are two carboxylic acid. One is methanoic acid, which is more stronger reducing agent, which can be oxidized by the even mild oxidizing agent, Fehling solution or Tonnage reagent. What is the Fehling solution? Fehling solution is actually the copper 2 sulfate solution dissolved in sodium hydroxide. This is Fehling solution 1, Fehling solution A and Fehling solution B, in which sodium potassium tartrate is also present. Now, the Fehling solution, when we treat Fehling solution with methanoic acid, it can easily be oxidized. And this equation is indicating in the methanoic acid, the oxidation state of carbon is positive 2. But after the reaction, when we use Fehling solution or Prolix reagent, it produces carbon dioxide, produce 2 protons with the removal of 2 electrons. It means the removal of electron is also indication of the oxidation process, and the increase in oxidation state is also indicating that oxidation is taking place. No doubt, this is a stronger reducing agent and can be oxidized by the mild oxidizing agent. Definitely, that can easily be oxidized using a strong oxidizing agent just like KMnO4 and K2Cr2O7. Could I find it? KMnO4, in case of KMnO4, the color change will take place from purple to colorless whenever the redox reaction will take place. And in case of potassium dichromate, the color change will take place from orange to green. So in this manner, the methanoic acid can easily be oxidized, producing carbon dioxide and the removal of electrons. Second is ethane dioic acid. This carboxylic acid is used in the redox titration to standardize KMnO4 solution. We take this ethane dioic acid into the conical flask and then add half test tube of sulfuric acid, and then we warm slightly and then add KMnO4 solution. And first of all, the purple color of KMnO4 solution decolorizes rapidly, and at the end point, one single drop of KMnO4 solution when produce a pink color in whole of the solution, that is our end point. Now the overall equation, balanced equation is written as 2MnO4 minus plus 6H positive plus 5H2C2O4. This is ethane dioic acid, which is also commonly called as oxalic acid. This produces 2Mn positive 2 ion plus 10 CO2 and then plus 8H2O. Now this manganese ion produced act as a catalyst and will speed up the reaction, and this is also an example of autocatalysis. Autocatalysis are those processes in which one of the product produced act like a catalyst and speed up the rest of the reaction. Now this is quite clear from the previous discussion and from the formula of both of these, that these two acids, methanoic acid and ethane dioic acid, can act as a reducing agent which can be oxidized using a oxidizing agent, stronger or weaker. Now this is all about the introduction of the carboxylic acid, their acidic strength, and the behavior on the basis of which they can act as a reducing agent and can be oxidized quite easily. Please do comment, share, like and subscribe the YouTube channel.